The topic that we are going to discuss today is streaming replication. So what does it mean by replication? The replication is nothing but replicating the things. So when I say replicating the things, okay, in the context of database, what we need to replicate? The database deals with the data. So the replication talks about replicating the data. Okay, replicating the data. What does it mean by replication? Or what does it mean by replicating? So sometimes we call it as a replica. What does it mean by replica? It is an exact copy. Okay, it is an exact copy of the. If you talk about database, it is a database. If you talk about something other, it is a exact copy of that. Okay, it is an exact copy of that. How we are going to achieve this replication, right? In Postgres, we have a concept of streaming replication. What does it mean by streaming replication? Streaming replication is nothing but, okay, we are going to maintain an exact copy of the production system. We are going to maintain an exact copy of the production system. Okay, so streaming replication in Postgres. Streaming replication in Postgres. Okay, so we are going to maintain what? An exact copy of the production. So why do we need to maintain an exact copy of the production? Streaming replication is a solution for high availability. Streaming replication is a solution for high availability. What does it mean by high availability? High availability means, let's say we have to think of a scenario where sometimes one of your production database is crashed. Okay, you should be having another alternative to reduce the downtime. Okay, whenever the database is down, will you be able to access the application? No. So high availability talks about what are all the ways that we are having. Okay, what are all the ways we are having to minimize the downtime. In case of in case of crash, or in case of anything unwanted things are happening to the your database. Okay, so one of the solution is what? Streaming replication. So how streaming replication is works, right? Streaming replication works, okay, streaming replication works by copying the val files from one system to the another system. Okay, streaming replication works by copying the val files from one system to the another system. Okay, so this we call it as a master slave configuration. This is a master server. Okay, this is a master server and this is a slave server. Both are, we can keep, okay, we can put both these servers on some different locations all together, and the slave server will be in sync with the master. The slave server will be in sync with the master by copying the val files. Okay, so why are we copying the val files? Is, if you remember, so whenever you perform any transaction, actual transaction is going to happen where? Actual transaction is going to happen in the shared buffer, whereas information about the transaction is going to get stored in the val files. Okay, so these val files are copied from source to target, or when I say like master to slave, to get in sync with the master. Okay, to get in sync with the master. This is how a streaming replication works. Okay, actually before going to what is streaming replication, so we will discuss, okay, we will discuss about the types of replication. Okay, we will discuss about the types of replication. We have two types of replication in Postgres. One is a streaming replication. One is a streaming replication and second one is a logical replication. One is streaming replication and second one is a logical replication. What is streaming replication, right? So whatever the changes that are happened in the master will be copied to the slave in the form of val files, and those changes will be applied onto the slave to get the slave in sync with the master. So here we are, okay, here we are maintaining the exact copy of the entire cluster. Okay, here we are maintaining the exact copy of the entire Postgres cluster. Okay, whereas in case with the help of a logical replication, what we can do, right? So instead of having a exact copy of the entire cluster, we will replicate couple of tables. We will replicate couple of tables or couple of schemas or particular database. So we are not going to have an entire copy of everything. So instead of that, what we are trying to do, we are trying to replicate couple of tables or couple of schemas or particular database. Okay, so the logical replication always talks about a specific object. Okay, a logical replication always talks about what? A specific object, whereas the streaming replication talks about entire database cluster. Okay, entire database cluster. So how the streaming replication is going to work? The streaming replication is going to work by copying the val files from source to the target. Okay, source to the target. Now the next point that we are going to read is like, so let's say, so this is my master server. Okay, this is my master server and this is my slave server. Okay, so here to here the slave is in sync with the master by copying what? Val files. Okay, by copying the val files. Okay, so val files has the primary source. They have to, you know, they have to receive over the network to the slave, and upon receiving of those val files, okay, upon receiving of those val files, what it is going to do, the slave is going to apply these val files on the slave side to get in sync with the master. Okay, that's how whatever the data, when I say sync, what does it mean by sync? Whatever the data that the master is having, the slave will also have the same set of data. Slave will also have the same set of data. Whenever something crash happens to this database, we can make the slave as a master and we can connect to this application to minimize the downtime, right? To minimize the downtime. What does it mean by sync? Suppose let's say you have a EMP table. Okay, you have a EMP table and you have done some changes. Okay, you have done some changes to that EMP table. The same changes will go here and there also. It will get applied. How it is going to get applied? It is going to get applied with the help of a val files. Okay, with the help of a val files. And one more thing is, if you want to, and there are two types of streaming replications that are available in PostGres. There are two types of streaming replications. So how many types of streaming replication that we have? This is very important. There are two types of streaming replication. One is asynchronous streaming replication. Asynchronous streaming replication. And second one is synchronous streaming replication. This is very important. Asynchronous streaming replication, synchronous streaming replication. Okay, so by default, okay, whenever you build a master slave setup or whenever you configure a streaming replication, by default it is a asynchronous replication. Okay, but if you want to build a synchronous replication, we have to change couple of parameters that we will be going to see it in our practical sessions. Okay, we are going to build a slave with a synchronous replication as well as asynchronous replication. Now we are going to see what is the difference between the synchronous replication and asynchronous replication. Okay, what is the difference between the synchronous replication and asynchronous replication? So in asynchronous replication, what happens, right? Before going to explain about the asynchronous replication, so I'll show you a diagram how the val files are going to get copied from master to the slave. Okay, so okay, see, so what is the purpose of this replication? So what happens, let's take this scenario where, so you have a primary server here. Let me take this. Okay, so what happened here? You have a primary server. Okay, here you have a primary server and we are maintaining a standby as well. Okay, this we call it as a master and this we are calling it as a slave. So what happens? There is a failure in primary. Okay, there is a failure in primary. So what we are going to do? We are going to switch. Okay, we are going to switch this primary. Okay, we are going to switch this standby as a primary system, as it is not available. Whatever the slave that we have, okay, whatever the slave that we have, we are making it as a master. This process we call it as a failover. Okay, this process we call it as a failover. That is one of the advantage with the streaming replication. And one more advantage with the streaming replication is, let's say I have a master server or primary server and I have a slave server or standby server. Okay, master can be called as a primary and slave can be called as a standby. And and I have a master server and I have a slave server. Okay, so slave server, we can put this server. Okay, by default we will be not able to access this server. Okay, though it is in sync with the master. Okay, we will not be able to connect to this database and we will not be able to perform any operations. But in Postgres we have an option to open this cluster in read-only mode. That concept we call it as a hot standby. What does it mean by hot standby? Hot standby in Postgres is nothing but we can open the standby database or slave database in a read-only mode. So whenever you open the slave in a read-only mode, what we can do? We can redirect the read-only sessions to the slave. What does it mean by read-only sessions? The sessions which are going to run the only select queries. Okay, though where it is not going to perform any inserts or updates or deletes or create table statements, the sessions. Okay, let's say in my project I have a separate application called BI reports, where the purpose of this BI reports is to generate the reports, which means if it wants to generate the reports, what it has to do? It has to read the data from the it has to read the data from the file. So that kind of applications we can redirect to the slave server, provided if you made the standby server as a hot standby. How to make this hot standby? That we will be seeing it during the streaming replication configuration. Okay, so one is the purpose of streaming replication. One is to get it to fail over. Whenever there is a crash, we can fail over it to the standby server to minimize the downtime. And the second part is we can do a read-only load balance. How can we do that? So in Postgres there is a concept of hot standby where you can open the entire database cluster in a read-only mode. So we can redirect the read-only sessions into the slave server, so that we are going to reduce the load on in the primary we can do write and read. Okay, but in the slave we can do only read only. So obviously whenever we are trying to redirect the connections to read-only connections to the slave server, we are reducing the burden on the primary or master server. These are the advantages of the streaming replication. Now we are going to see the streaming replication mechanism. Okay, so as I said, the streaming replication is how it works. The streaming replication is going to the streaming replication is working by based on copying the val files. Okay, that we call it as a val transfer. From where to where those val files are going to get copied? The val files on the source is going to get copied to the slave server. The val files on the primary are going to get copied to the slave server. Why from primary to slave? As I said, the standby server is in which mode? Read-only mode. Okay, when the standby server is in read-only mode, do you have any chance of modifying the data? No. Do you have any chance of modifying the data on the slave? No. So whatever the modification that you have to do onto the data, what you need to do? You need to connect it to the primary server and you can perform. So actually what happened in this scenario, if you see, we have connected to the primary system. Okay, we have connected to a primary system. He performed some update operation where the code 123 is updated to what? 124. Okay, actual update is going to happen where? This is a shared buffer. Okay, actual update is going to happen in shared buffer, whereas the information about that update, the metadata about the transaction is stored in val files or val buffer. So this is how it is going to get stored. For ID 1, update code to 124. So these val files are going to shipped onto the standby over the network. Over the network, this val files is traveled to the standby. On the standby, the same thing has been re-executed or reapplied, so that the master and slave both are in what? In sync. Both are in sync. So whatever the changes that are applied on the master will be in sync with the slave. So will be in sync with the slave by applying the val files. So these val files are going to get traveled over the network to the slave, and the slave is going to receive, and slave is going to apply. Okay, slave is going to apply. So to understand, okay, to understand more on this, okay, so what we'll see the functionalities, okay, how it is going to work. So I have a master, okay, I have a master server and I have a slave, right? So what is the responsibility of the master? Master has to send the val, right? Master has to send the val, slave has to receive the val, slave has to receive the val, and slave has to apply the received val. Slave has to apply the received val with the things in mind, okay. Master has to send the val file, slave has to first step is master has to send the val file, slave has to receive the val file, and slave has to apply the received val. With the steps that are in mind, I'm going to introduce, okay, I'm going to introduce the processes that are involved in the streaming replication, okay. Processes that are involved in streaming replication. So what are the processes that are involved in streaming replication is, one is a val sender process. The same steps, okay. One is val sender, val receiver, okay. One is a val sender and val receiver, and third one is a reply process. Replay process, not reply. It is a replay. These are the processes that are involved in the streaming replication configuration. Okay, we will be seeing one by one how the val files are. Okay, sorry, not a replay process. I'm sorry, it's not a replay process. What it is, right? It is a startup process. 1 minute. Val sender process, val receiver process, and startup process. Okay, val sender process, val receiver process, and startup process. Okay, so what is this val sender process? Val sender process sits on the primary or master server and it is going to send the val files. Okay, val sender process is going to send the val files to the what? Val sender process is responsible for sending the val files to the slave. Val receiver is going to receive the val files on the slave. Startup process is going to apply the val files. Okay, startup process is going to do what? Apply the val files. Okay, so val sender is going to send the val files. So val receiver is going to receive the val files. Okay, how val sender is know which val file it has to send it to the slave, how it knows, right? So val sender, okay, val sender is always in sync. Val sender is going to communicate, sorry, val receiver is going to get in touch with the val sender and it will send a communication that till what LSN it has received from the primary. LSN means log sequence number. Okay, it resides in the val file. Okay, so val sender is going to send a communication to the val receiver is going to send a communication to the val sender with the latest LSN number that it has received and applied. Okay, upon accepting this information, val sender is going to send the val file starting from this LSN to the latest LSN. Okay, starting from this LSN to the latest LSN. What does it mean by, okay, let's say I have 1, 2, 3 and so 100 LSNs are there. 100 LSNs are there. Okay, now what receiver will do, right? So let's say this is a val receiver. This is an example. Okay, you don't think like LSNs will be like sequence number. It's not. Okay, so this is a val receiver. Okay, what val receiver will do? Let's say our master and slave are in sync till 50th number. 50th LSN slave is in sync with the master. Okay, so upon what val receiver will do, right? Val receiver will send the information to the val sender like till 50th number I got the val files and I have applied on the target, which means it is target means it is a slave. Okay, then what val sender will do? Val sender starts sending the val data from 51 LSN to what is the latest number? 100. So whatever the changes that are happened till latest time, it is going to send the val file. So val receiver is going to receive those val files and val receiver is going to apply those val files on the slave side to get in sync. So to get in sync, To understand more on sorry to understand more on this, we are going to see a simple diagram. Okay, so val sender, val receiver, and startup process. Okay, forget about some of the terms like so val sender will be on the master, val receiver will be on the slave, and val and the startup process will be also on the standby side or slave side. Primary, master both are same, slave and standby also same. The names might differ, but the functionality is same. What is val sender? Val sender is a process which is responsible for sending the val files. When you start what is val receiver? When you start the replication, a val receiver process sends the LSN of the val data. So from that val data to till the latest time, val sender is going to send the val data to the slave. Startup process, okay, whatever the data that val data that it has received, it is going to apply this val data into the standby server. Okay, that's how a master and slave both are in sync. Both are in sync. Okay, now let me have a quick glance of how actually it works. Once it is done, we are going to discuss about the differences between the streaming replication, synchronous replication and asynchronous replication. Then only you will understand. Okay, now, so what is this? Okay, so this is my primary server where a user is sitting and he is performing some operations on the primary server. Okay, whatever the changes that are so this is the first step. There is an update of table that has been happened, right? The second step is there is a update of a table that has been happened, and whenever an update is happening, the actual update is going to be stored in table, whereas whatever the corresponding val, okay, whatever the corresponding val will be received by the val sender, and this val sender is going to send the data to val receiver, and val receiver is going to receive this val file, and it stores in the pg underscore val location of the slave side, and from this startup process is going to read this, and startup process is going to perform the same operation on the table. Okay, it is going to perform the same operation on the table. What this report says that here there is a report and here there is a report. Whenever there is a change, some mechanism will be there in the PostGres to report the val sender that, hey val sender, some updates has been happened, so you need to ship the val data. Likewise, whenever val receiver receives the val data and keep it in the val buffer, okay, keep it in the pg underscore val location, then there is a report. Okay, then the startup process is going to get intimated that, hey startup process, we got some val data, so now your work begins. So you need to pick up that val data, and you need to you need to apply that val data. That's how this entire mechanism is going to work. Okay, can someone go on mute? Okay, so this is how a val file is copied from the primary to the slave. Okay, so but now the synchronous and asynchronous replication comes into picture now. Now how the synchronous and so what we are doing, whenever there is an operation that is happened, the val file is getting copied to the primary to the slave. So what synchronous replication talks about, right? What synchronous?
Hari, you are in mute.
I'm sorry. Yeah, so what synchronous replication talks about, right? The synchronous replication talks about, okay, so whenever it is going to send the val file, okay, whenever it is going to send a val file from primary to the slave side, when you configure the streaming replication in a synchronous mode, the primary server or master server is expecting an acknowledgement from the what? Expecting an acknowledgement from the slave server that so and so val file has been received. Okay, so and so val file has been received. Whenever you configure a streaming replication, okay, whenever you configure a streaming replication in PostGres, okay, whenever you configure a synchronous replication in PostGres, okay, then after sending a val file, okay, after sending a val file to the See, here it is. After sending a val file to the slave server, the primary is expecting an acknowledgement from the slave. So what if the slave is not going to send an acknowledgement? If the slave is not going to send an acknowledgement, the primary will be in hung state. Okay, the primary will be in a hung state, and okay, the primary will be in a hung state. But what is the advantage of this synchronous replication? The advantage of the synchronous replication is the delay will be very less. The delay will be very less. How we are saying the delay is very less or lag is very less? How we are saying is right. So I have a master server here. I have a slave here, and I kept a synchronous replication in between them. In synchronous streaming replication in between them. So master is always waits for the acknowledgement from the slave. Okay, this is a master and this is a slave. Okay, so a master is always always awaiting for the acknowledgement from the slave. So let's say if there is a network break happened between master and slave, in this case what happens, the slave might be not able to send the acknowledgement. Okay, when the moment the master did not get the information or acknowledgement from the slave, then it thinks that it is the slave is detached from the master, and the master will be the whatever the operation that are happening, the master will be not allowed. Okay, master is not going to continue with the transactions. So that is the reason why. So whenever there is a network outage, what happens, the master will also will be in hung state. So there are and master is not going to accept any operations. If the master is not going to accept any operations, whatever the things that are the changes that are there in the master, the same changes always there in the slave, and there is no there is no lag, or there is no lag, or there is no sync issues between the master and slave. So coming to the asynchronous replication, master is not going to wait for any acknowledgement from the slave. This is my master, this is my slave. Whenever you keep master and slave in a asynchronous mode, whenever you keep the master and slave in a asynchronous mode, then it is not expecting any acknowledgement. Okay, master will not expect any acknowledgement from the slave server. When it is not accepting when it is not expecting any acknowledgement from the slave server, it is continues to perform its operations. Let's say there is a network outage between master and slave. Does master really cares about this network outage? No, master is going to continue its operations. Let's say there is a network outage of 2 hours. Okay, so the slave is behind 2 hours with the master. Okay, behind 2 hours with the master. Okay, after 2 hours, if the master is down, do we get the latest data here? No. So you have to fail over to the slave. Okay, you have to fail over to the slave. When you fail over to the slave, okay, the slave is already behind 2 hours. Okay, you will not get the latest data, and you will lose some data. How many hours of data you will lose? The latest 2 hours of data you will lose. Whereas in synchronous replication, as master always waits for the acknowledgement from the slave, both will be in sync, and the loss of data is in milliseconds only. The loss of data will be in milliseconds only. Whereas in case of asynchronous replication, depending upon the lag, we are going to lose the data. That is the difference between the synchronous replication and asynchronous replication. So now we will see the differences in C. For streaming replication, you can select either synchronous replication or asynchronous replication for each standby server. What are the synchronous and asynchronous replication that we are going to see? The difference between the synchronous replication and asynchronous replication is whether or not to wait for the response from the standby server before completing the process. Okay, now we will see the differences. Okay, so the synchronous replication, the primary server waits for the response from the standby server. Okay, the primary server will not wait for any response from the standby. And the asynchronous replication is what? The default replication method. And since there is no delay in the val shipping, okay, so the data is always in sync. So we might have some delay in asynchronous replication we might have some delay in the some delay in the process, so we might lose some data. Okay, so where synchronous replication will be used, synchronous replication will be used for the read only load balancing operations, whereas asynchronous replication is used for the disaster recovery. So so most of the environments we will be having a asynchronous replication only. Why we will be having an asynchronous replication? Because if you kept the synchronous replication, if something happens to the standby, we will not be, the primary also will not be accessible. So to avoid that, to avoid the downtimes, we don't prefer to go for the synchronous replication. But in our session we are going to see how to perform, okay, how to configure streaming replication both in synchronous modes and asynchronous modes as well. So with this, so we have completed, okay, with this we have completed the theoretical part of the streaming replication. In the next session we are going to see how to build a standby server, okay, and how to configure a synchronous replication, and we are also going to see how to configure an asynchronous replication in PostGres, and we are also going to see how to create a lag and how to recover in case of lag. What are the operations that needs to be taken from the DBA side whenever there is a lag between master and slave. Those things we are going to discuss in detail in our next session. That's it for today, and tomorrow we are going to start the configuration of the streaming replication. Thank you.